let's get into our networks here. So I titled this form and function, and I got some animations in here. Sometimes they work better than others. For many years, as vehicle manufacturers added new features to their vehicles, they continue to add more sensors, actuators, wiring to accommodate these new features. These additions added more complexity to the vehicle and required a larger and more expensive central computer. So, for example, before electric cooling fans were first controlled by the powertrain control module, it was not uncommon for an engine to have three coolant temperature sensors or switches, one for the temperature input to the PCM or engine control module, one for the electric cooling fan operation, and one for the coolant temperature warning light or gauge on the dash. So this what? Added redundancy. Now we got three sensors, we got three wirings. That's three times the number of connectors that can melt, go bad, anything else. Plus we're adding what? A lot of weight. So these extra sensors were redundant, added weight, which meant less fuel economy to the vehicle, and added more potential for system failures, shorts, opens, and so on. Plus we had to figure out places on the engine to put all these sensors. To eliminate these problems, manufacturers changed to a network system. So my question is, a network system can use a single sensor for many modules that need the same information. Do you think that's true or false?
True.
True. Absolutely. And we've talked about this a little bit, how I can use the ABS sensors to tell the transmission how fast we're going, tell the speedometer how fast we're going. We're able to share all this information, so I don't need all these extra sensors.
Mr. Brian?
Yes.
Good morning, Mr. Ryan.
Morning.
So these single sensors, I just want to be clear on that side. If you're using a single sensor, you must have like two types of, you can say, sensors inside that single sensor in case if one fails, at least it has a backup, or just like a total pedal, or no?
No, a lot of them don't have a backup. So if I have something that's not working in multiple systems, so example, I have a code in my engine for the vehicle speed, and I have a speedometer that doesn't work and a transmission that doesn't shift quite right, I'd go looking for wherever that vehicle speed signal comes from, whether that's a single sensor in the transmission or differential, or whether it's getting that information from the ABS module. Obviously, it's an information problem because multiple systems are affected. On the other hand, if my speedometer stopped working on my dash, but if I plug in a scan tool and talk to the engine computer and it knows exactly how fast we're going, that means that there's nothing wrong with my sensor. The problem is in my instrument cluster. It's in the dash. So by using one sensor, and many times there's not a backup, although sometimes there is. If I have multiple systems go down that all rely on that sensor input, it's a sensor problem. If I only have one system that's not working, it can't be a sensor problem because the other systems that use that same sensor are working fine. So it really helps us kind of figure out what's not wrong.
In that case, in case if the sensor goes bad, so the computer pretty much turn on the fan just like as a default. And what about the fuel tank? Like, how does he know that the engine is warm enough to be efficient?
Right. Okay. So back to the fan scenario. You're right. So if my coolant temperature sensor went bad, depends on how it goes bad. Did it go? It depends on whether the computer recognizes. So say it goes bad and the computer recognizes that it's bad. It could do a couple of things. It could turn the electric fan on all the time. Because you're right. We don't know when the car is overheating, so we're going to make sure it never overheats. The other thing that might happen is that maybe you don't get air conditioning anymore, because air conditioning would make the engine run hotter. And since I don't know the temperature of the engine, I'm not going to let you have air conditioning. So the customer might not even notice the electric fan on all the time, but they might bring this car into the shop because the air conditioning doesn't work.
So it limits the functions of the car pretty much.
Yep.
Okay.
And we can see here there's a lot of different modules here, isn't there? And this is only a fraction of the ones available. You know, 2 years ago, a Pan America could have up to 168 different modules on it. So we can see here, there's a lot of different modules, everything from interior lighting to our instrument cluster, adaptive cruise control, tire pressure monitoring, blind spot detection, transmission control, OBD2, security system, and so on. Well, I don't want to have 30 sensors because I have 30 modules that need the same information. I want to use one sensor, and we're going to put it on a network and we're going to share it with everybody. So not only do we have networks, but we have multiple networks on the vehicle. So these systems are not all on one network, and there's a couple of reasons for that. One is all of these don't need to communicate at the same speed, right? So if I want to put my passenger's window down, and it takes 0.2 of a second or 0.3 of a second for that command to go over to that passenger door and put the window down, I'm never going to notice that. I'm not going to see that as a delay. But 300 milliseconds it takes for me to decide to deploy the airbag, that's a long time. So these different systems will operate at different speed based on what they're doing. So our ADAS stuff, our advanced driver assist, so our automatic braking, those kind of things tend to be on the highest speed network. Next is our powertrain control. So that's going to be our engine, our transmission, usually ABS, and airbags are on the next fastest network. Then we get into the slower networks. Oh, that's the radio. That's the power seat. You know, that's those things, maybe even air conditioning or body control. Those are the things that, yeah, we don't need to do it in 0.003 of a second. 0.03 of a second is fine. So why spend the money on the faster system? Plus, by having multiple systems, if there's a problem, only part of the car stops working. Now, the car may or may not be able to be driven depending on where the problem is and what happens. But if it was all on one network and something happened, now we're definitely walking. So by having multiple networks, it puts the ability for the car to get you to your destination, even if there's a catastrophic failure most of the time. So a local area network, and this is just a generic term, a LAN, eliminates hardwiring of sensors and actuators to every component, such as the PCM, warning lights, fan, etc., which results in lower production costs. So it's kind of funny when you think about it that it's cheaper to put in a computer than it is to put in all these sensors. And that's because computer technology has gotten so cheap. You know, I finally broke down and bought a rear view camera with a front view camera on the mirror with memory and 24-hour monitoring if I want, all this other stuff. $120.
I have a question.
Yeah.
The previous picture shown the 47 sensors, but which one is the local area network connections? Most of the important connections.
That picture doesn't show it. That picture is just an example of some of the different modules that we have on the car.
Yes, sir. But local area network, LAN, how many connected each other?
Depends on how the network's designed. Might be 3 modules, might be 12 modules. It depends on the system.
I got it.
And how many options the customer got. So but no, it's amazing. You think about it, 2 high definition cameras, a computer, a monitor, the mounting, all the wires, everything else delivered to me for $120. So when we think about production costs, this electronics has gotten really, really cheap for vehicle manufacturers. And by doing this, we eliminate redundant components and wiring, which reduces weight, better fuel economy. If you want to look at things that get changed on the automobile, going back 60 years, 70 years, the 2 driving forces are fuel economy and safety. And in the last 40 years, I challenge anyone to come up with something that's not related to fuel economy and safety that we've changed on the car in the last 40 years. And I do this with every class, and I haven't lost yet. So I'm looking forward to any suggestions you guys have.
Akbar, यहाँ आओ.
But it's all about fuel economy and safety today. That's what drives the change on the automobile. That's what makes a 2020 different than a 2010 is those two things.
3 fruits. नहीं वो खराब हो रहा है.
Reduces potential system failures. Obviously, the less connections I have, the less wires I have, the fewer things that can break. And then information transfers faster between component systems. So in other words, because our networks could be at different speeds, and even our slow networks are pretty doggone fast, we're able to transmit this information very, very quickly. So which of the following is an advantage of having a network system on a vehicle?
All of the above.
All the above, you got it. And just in case you haven't already guessed, when we get done with this PowerPoint, I will turn on a quiz on Canvas, probably on Monday. It'll be a PowerPoint review for this PowerPoint. That, guess what? We'll have all these questions. And these questions are also questions that might be on the midterm. So just FYI. I try to be transparent. So network communication. So how does all this information get transferred on a single or two-wire network? Isn't there going to be a traffic jam of information going to and from modules? So, you know, you think your traffic's bad now. Think about having to drive in this. Right? And why does traffic work? We have a lot more vehicles now than we did then. Fewer horses, but a lot more cars. But it works because we have rules, right? We have rules. We have, you can only go on a green, you can't go on a red. You know, we have rules in place. Same thing is true on networks. And if you think about whether you're using a phone line for your internet or using a cable for your internet, if I'm using cable, I have what? Talking to you folks. My wife's in the other room watching TV, and she may get on the phone while we're on, and our phone is also. So all this is happening in that same single wire in the middle of our coaxial cable. Because if you ever open up coaxial cable, there's just a single wire going down the middle of it. And so all this information is happening at the same time on our same network, but it's doing different things. And that's because there's network rules. So every network has two things. It has the physical structure of the network. So how many wires does it have? What voltages do they operate at? Those kind of things. That's our, you know, physical network. The other thing we have in a network is the protocol. The protocol is the language of the network. And different networks have different language and different rules within that language. And you know, anyone who speaks more than one language and has looked at all, different languages have different rules on how you use certain words or how you use certain, you know, in some languages, nouns are masculine and feminine, and in other languages, they're neutral, they're not. In some languages, the word the is masculine and feminine. In other languages like English, it's not. So there's a lot of rules that different languages have, and network systems are the same way. They all have certain rules. Now, I did turn on an article that's a homework assignment, very similar to the one you guys did on the state lamp manual. And this is an article from Bosch, and Bosch invented a certain type of network technology called CAN, or Controller Area Network. And so I have an article on that. It has lots of pictures, so it goes quick. I like articles with pictures. And a homework at the end of it. And it's not timed, so you can read the article, find the answers, and fill it out. But that is also in this module. Because I think they do, they invented the technology, so let's let them describe how it works. And instead of someone who read that and re-explains it and re-explains it. And the article is pretty good and easy to read, so that's why it's there. So in general, the system employs a data bus or bus of 1 or 2 wires to carry individual information packets, sensor outputs, computer commands, etc., throughout the network. So the keyword here is packet. So because our signals come out of a computer, they're a digital signal. So, right, because our computer can't make an analog signal. An analog signal is like a waveform. It is very freeform. Computers, since they only have ones and zeros, it either is on or off, which is digital. So what we do is we use a technology called packet technology, which goes back well before computers. As far as local computers, we actually used it in ham radio, and we actually sent information packets over amateur radio. And so it's been a way of doing things well before we used it in the automobile. But what it is we're going to bundle up a bunch of stuff. So instead of sending individual words, we're going to kind of take these files and create, to make a computer term, like a zip file. We're going to compress it and put it into this little packet. And we're going to send this packet with an address to a specific receiver or receivers. So that way modules that don't need the information will ignore it. Modules that do need the information, they're told before they even read the packet, hey, this is for you, or there's stuff in here that you need to know. And so we see these little blurps of data come across, sending messages, and there's distinct message structure on different networks, which we're really not going to get into message structure here. That's a whole different thing. I just want you to be aware of it.
So Brian,
yes.
I'm sorry. I think you did said this before, but what is the difference between the high and the low on the car for the networks?
Oh, you're not talking high and low on the networks. You're talking about the high side and low side of like a CAN line.
Yeah.
Okay, that's in the article, so you'll enjoy it. And I will also get to it in the PowerPoint.
Oh, okay, we're not there yet. Okay, thank you.
Yep, you bet. Right now, I just want to talk about what a network is and how they work before we get into the nuts and bolts, because the nuts and bolts to a guy like me is really interesting because I'm trying to fix them and I geek out on the stuff. But for a lot of people, they just kind of want to know, how's this thing working? Why does it work this way? And the nuts and bolts don't make sense unless we talk about this. So think of the bus as a freeway. So this is our network as a freeway, a physical freeway, and with on-ramps and off-ramps to cities, i.e. modules that can exchange information. So here we're coming up on the trans module, then the HVAC module, then the dash module, right? So I got an information packet and we're going to be sending it to mod. Oops, got it. And the cars are like information packets traveling on the bus, delivering information only to be delivered to the correct destination. And so obviously higher priority packets, like we just got in an accident, deployed the airbags, takes precedence over the customer hit the button that would like air conditioning, right? I mean, so we have different priorities, and in the program, the computers are programmed to decide what is really important. The car is overheating versus the coolant temperature is 120 degrees. Well, that's nice, right? I mean, so different, just like in our language, different things have different levels of importance, and based on that importance, our voice is going to be different. You know, I know as a parent, right? You tell your kids no, and then when they're in danger, no sounds a whole lot different, doesn't it? Because you're scared for them, it comes out, and the kids know that no is very different than the normal no, don't do that. Stop doing that. So information on the network should be is carried in which of the following ways?
Packet.
Which way?
Digital.
Digital
No,
and packet. So it would be
2 and 3, number 4.
number 4. Always got to read to the bottom. So it is packet. It's a packet of data, but it's a digital signal. And that's why I put number 4 there. So here is a basic looped network. And so here we're going to the DLC. And then it goes to, in this case, our imaginary local area network goes to the HVAC module. And then from there, it goes to the radio, the cluster, and the memory seat module. Now, on this particular system, communication is allowed to go forwards and backwards. So if the wire got cut between the memory seat module and the instrument cluster, everyone would still talk, even though I get a code. But if the wire broke between the HVAC module and the DLC where the scan tool communicates, which is the diagnostic link connector, then no one can talk. So depending on where the failure is in the network and depending on the rules of the network, so some networks like this can go back and forth, other networks can only go in one direction. So if my network says, hey, we can only go counterclockwise, in that case, if there is a break here, only these modules would be talking back to the HVAC module, but none of these modules would be able to talk to the HVAC module because communication would only be allowed to go one way. If the break was here, then only the memory seat module and cluster could talk to the HVAC module. And these two modules would never hear a story from either one of those. So you again, it depends on the rules set up or the protocol. Can I talk in either direction? Can I only talk clockwise, counterclockwise? Another thing that we have is relationships in networks where some modules can only speak when spoken to. And they normally call that a master-slave relationship, where you have a master module and a slave module. And the slave modules are only allowed to provide information when asked by the master module. When I was growing up, they called it a parent module and a child module because we were only allowed to speak when spoken to. Something about children being seen and not heard is what I was told a lot as a kid. I didn't listen well, so I still talk.
So Brian,
Yes.
that protocol that you're mentioning about the, if it goes clockwise, that information, where can we find it? Or is it going to be the diagram or?
No, it won't be in the diagrams. It's going to come into the protocol rules. So you find that two places. One is the general information, all data or wherever, are going to tell you what kind of network it is. So they're going to give you the protocol. Now, once you find out what protocol it is, now you need to have a knowledge of that protocol. So the one that only works counterclockwise is a MOST protocol, which is media-oriented something transport. But it only works counterclockwise. So MOST has very specific rules. FlexRay has very specific rules. So a lot of it is finding, so like I teach a network class and which I've taught before, which gets into these different protocols, and here's the rules that these protocols have to follow. And there's some of that in the class because a lot of times a manufacturer will just say, oh, it uses this. Well, if you don't know how this works, that's a limited amount of information. So you have to kind of get that information from a lot of different places. And sometimes you might find out that, oh, it uses this, a UMG network. What the heck is a UMG? Where's Google at? Right? Let me type in Volkswagen UMG network and see what it says. Or let me type in BMW FlexRay and see what it says. And maybe I need to get my information that way. I mean, there's a lot of junk on the internet and a lot of junk that you get when you do a Google search, but there's also, I have found some awesome information. Unfortunately, it seems to be on about page 3 or 4 sometimes. But I found some awesome information doing research using Google, trying to find different answers to things I wanted to know. And a lot of times you kind of got to get past some of the chat rooms and get past some of the other stuff, although sometimes there's interesting stuff in chat rooms. But I found white papers, I found research documents, I found great technical articles. I found stuff that's like, whoa, someone put this 200-page article where they're going in way deeper than I can even understand, much less need. So, I mean, there is a ton of information out there. You just got to be willing to do a little bit of data mining. And I mean, I've spent an hour or two before just trying to find the answer to something because I wasn't going to stop till I got the answer. Then the trick is remembering the answer the next day.
Yep. So,
Right.
so pretty much from your point of view, when it comes to diagnostic, so these network systems are the more uh, difficult to do. Pretty much sounds like.
You dropped out a little bit there, Alberto.
Oh, I said from your point of view, the network system is the more complex to do diagnostic on. Sounds like
No,
it.
I don't think so. I would rather work on a 2018 or 2015, whatever, 2020 car with a network than a 1985 or 90 car without one any day of the week. Because the diagnostics that I can do without actually going in and taking things apart or doing testing is so much more. I can do so much more external diagnostics much quicker on a modern vehicle than I can on a 30-year-old vehicle. Now, that being said, if I figure out that I have a wiring problem or I have a problem actually in the network, that can get very time consuming to solve, but at least I figured out for sure that's what the problem is. I'm not, bumping around blind, hoping I find something, or maybe it's this, let me take it apart and look. Maybe it's this, let me take it apart and look. On a modern network vehicle, we don't do this. On a modern network vehicle, we can normally isolate, look, here's where the problem is. Here's how many hours it's going to take me apart to get there. Very similar to what we were able to do with Rob's car, where we were able to look at the schematic. Hey, we got power here. The next stop on the powertrain is the ignition switch. It's hard to get to, but based on our external diagnostics and our high level, just checking stuff that was easy to check, we know that's where we have to go next. And we know either that's where the problem is or the problem is in the wire between where we've already tested and that ignition switch. So it makes sense to go to the other end of that wire instead of tracing the whole length of the wire. And we're going to do the same thing with networks.
Thank you, Mr. Ryan.
You bet. And networks do get a little more complicated. So this is a pretend network, right? We just drew it up. Here's a real world network. Whoa. My head hurts. I'm not ready for this. So this is like I took you in the pool at the 1 foot level. We walked to the other end and I threw you in at the 12 foot, right? I mean, I just dumped you in deep here. But it's not as bad as you think. So we have multiple modules, multiple loops here. And what we normally do is get a highlighter out and let me start highlighting some things and see what I can figure out. And so what I did here is I have my diagnostic link connector and it comes over to this splice. This happens to be a single wire network. This is GM. And then if I trace this in green, so these are what we call daisy chain, where it comes from one module to the next module to the next module. So any break in here, isn't this a series circuit? I only got one path to go from here to here. That's a series circuit, isn't it? So just like any series circuit, any break in here would not let me communicate with anything after the break. So if this wire right here had a cut in it, I wouldn't be able to talk to these three modules, but I could talk to this module. So going back to your question, are these systems harder? No, not really, because if I have a scan tool and I can look and I can talk to this module, but I can't talk to these three modules. I might check to see if these three use the same fuse or something like that. But if that's not it, my problem has to either be this module or this wire. So the next thing I'd want to go is go to that module. So I'm not guessing. I'm not having to pull the whole car apart. I can kind of figure out pretty quickly where the problem has to be. My little purple loop here, and we could draw this a couple different ways, but it shows again how we're daisy chained through here. But this loop is a true loop. So if I have one broken wire, I can still talk to everybody. I have this other little loop over here that just, again, is a little series thing. I have another that I did in red here. So here's another loop, and we can kind of go back and forth. But what we do on these is we kind of just do a little bit of drawing and look to see, hey, where does communication go? How can I get from point A to point B? Which modules are talking? Which modules aren't talking? And try to figure out where the problem might be. So if I can't talk to anybody, then I know that the whole system's down. And usually if the whole system's down, either I have an open between here and here, or something has shorted the network, either to power or ground. Okay, no problem. Thank you for letting me know. So it allows us to really kind of, we're spending more time fixing the car up here and a little less time fixing the car down here. Because now I'm gathering information, I'm going to my resource like this, and I'm trying to figure out how the system works. How many modules are there? How many can I actually talk to? What codes do I have? Who has codes? Who thinks they have a problem? Who thinks they have a problem with somebody else? Because network codes are kind of unique, and that the module that's bad normally doesn't set any codes. It's everybody else that sets a code. So for example, we're in a Zoom meeting or in a meeting, and say someone falls asleep. They might fall asleep for a minute or 2 minutes and wake up and not even realize they fell asleep because they're exhausted. I think everyone's done that. I get yelled at all the time because I'm snoring in my recliner. My wife says I fell asleep, and no, I didn't. I'm watching the movie.
Yep. Same with my husband.
Yeah. So,
Mr. Perrin,
yes.
how do you know which one is talking to whom or who is asleep? What tool?
Right. Well, we use a scan tool, and I'll get more into scan tools as we move into more engine management stuff. But it's a tool that I actually connect right here on this system, and it allows me to talk to all these modules. And what happens is the modules that didn't fall asleep tattle on the module that did.
That's even bad.
So if you go in and I got codes in 5 modules saying, hey, I couldn't talk to Mr. ABS. I couldn't talk to Mr. Analog Braking System. And I go talk to Analog Braking System. He goes, everything's good here. I don't know what they're talking about. Guess what? I have a problem with the analog brake module or the wiring going to it. And it's probably not the wiring, because if it was the wiring, he'd say, hey, I couldn't talk to these people. But the fact that 5 modules say they couldn't talk to ABS, and ABS says, I don't know what they're talking about, everything's great, that's a problem with the ABS module. Either it's losing power or ground, or the module itself's bad. So unlike a lot of things we do on the car where we get a code that's for a specific thing, or the module that has a problem is the module we're trying to fix, with network issues, usually the module with the problem thinks the world is perfect. It's everyone else that's tired of listening to him snoring.
It's in a state of denial.
Yes, absolutely. So, I mean, that makes it kind of interesting. So I like this. I like network stuff most of the time. Sometimes it's a hassle because access to some of these modules stinks. But it is it's just kind of a little puzzle, Some scan tools give us a lot of help. So this is an example of a scan tool. This one happens to be laptop based. And this is a factory Chrysler scan tool. And what it does is it shows me my networks in different colors. And I don't have the legend brought up here because I want to make this picture bigger. But you see the pink here, that's one network just between where my scan tool plugs in and what we call a gateway module. And then the black is a high speed network. And my blue is a lower speed network. And the stuff that's in gray is not on this vehicle. So those are optional things. The little lightning bolt tells me that there is updated software for all of those modules. But it's not super important, because it was important it'd be like red because it's an emergency. This is just, by the way, there's new software. Kind of like your computer goes and says Windows has an update, same kind of thing. And then in red here, you see the red in the red line, that's a module that's not communicating. And on this particular vehicle, we found a wiring problem between here and here that we fixed. And it's a passenger door module is what that was. So this is off a real vehicle we fixed, but this is called network topography. And right now, no aftermarket scan tools do it, but there is a few factory scan tools that do this and put this out, and we can see exactly who talks to what and where they're at and who showed up for work today and everything else. So and I really expect to see aftermarket scan tools do this within the next 5 years, because we're seeing right now Nissan, BMW, and Chrysler all do this. Mercedes kind of does a version of it. So I think as more and more factory scan tools start doing it, we're going to see it on the aftermarket to become more and more available. But this is just a neat feature. This is kind of saves me the trouble of going and pulling the wiring schematic up like I did on the last slide, getting the highlighter out and doing that. So this is just, I just put it in here as eye candy for you. So a vehicle may have more than one network. Is that true or false?
True.
True, absolutely. If you said false, now I know you fell asleep and we need to do some diagnostics.
Mr. Brian,
Yes.
I have a question. So those modules, it's just that when you were talking about these modules, I remember I saw this on an assignment that I did. The TPMS module, because I know Toyota has a button that you press. Well, it says right there when you are doing a TPMS sensor relearn, you shouldn't press that button because the system is going to go on closed loop. But my question is, because and once you do that, if it goes in closed loop, you have to take it to the dealer so they can pretty much access to it and pretty much reprogram the whole thing. So my question is, if that was the case, that it could happen, why do they do that? Why do they put a button right in front of you, like right under the
Well, the button is there as a reset. Using that reset button on the Toyota TPMS doesn't mean that you have to go to the dealer. If the button's not working or the light's on after you push the button, then that's because there's a sensor issue. And the sensor issue could be a bad sensor. I've also seen on Toyota truck products. Toyota truck products have two different sets of TPMS sensors that can be programmed, one for summer tires and one for winter tires. And sometimes things get toggled over and they're trying to reinitialize the wrong set of tires. And that's something else that the customer has the capability of doing, switching between summer and winter on those Toyotas. So I've seen both of those be a problem, but just pushing that button doesn't make it have to go to the dealer.
Okay. It's good to know because that's what I said on the assignment, and that's what it says. Like when you are doing a relearn on the TPMS sensors, do not press that button. You press that button, you're done. I was like, what? Okay, thank you.
Mr. Perrin,
Yes.
will the scan tool tell you whether it is the sensor that's problematic or the actuator?
What the scan tool will do, and we'll get into this coming up, what the scan tool will do is give you an area that first of all the scan tool does, the scan tool is a dumb address book. The scan tool knows who lives at what address, and it knows how to talk the language of each house it opens up. So it may go to the transmission control module. And it may say, do you see where you have any problems? And the transmission control module will say, yeah, I have a problem with my 3/4 shift solenoid. So now that could be a bad solenoid. It could be bad wiring, or it could be that the transmission is broken inside and can't go into 4th gear. So when we turn the solenoid on to shift from 3rd to 4th, it doesn't shift. So we may set a code saying, oh, the solenoid must not be working because we didn't get to 4th gear, where in reality, there's no 4th gear because it burned up, gone, valve body, whatever. So codes in a computer are like going to the doctor and saying my throat hurts or saying that my elbow hurts. So there's a lot of causes that you could have with the same symptom, and codes are the same way. So there is no code that tells you what part is bad. There are codes that tell you which system is not performing correctly. And then you have to look to see what does it mean by not correctly, and we call that enable criteria, and that's something that we can look up and see what actually, what the computer saw to set the code. So did it set a code because, oh, it's electrically open? Well, that would be a circuit code. Did it set a code because we didn't get fourth gear? That's a logic code. So codes are divided in two areas. They're divided into circuit codes. I should have 12 volts here and I don't. I should have 5 volts here and I don't. I should have 0 volts here and I don't. So if we set codes for the circuit being in the incorrect condition, the circuit code. We also set, and most codes are logic codes. I turned the light switch on and the light didn't light up. So I'm going to set a code for the switch. Because when I turned the switch on, I waited 5 seconds and the light didn't come on. Therefore, I'm going to set a code for the switch. And, well, is the switch the problem? I don't know. Maybe it's just a burnt out light bulb. Maybe it's the lamp came unplugged. Maybe, I mean, there's a lot of possibilities. So codes are really just a symptom. They're not a diagnosis. Does that help, Sonny?
So Brian,
Yes.
just from your point of view, which scanner would you recommend that you said, oh yeah, with this scanner, pretty much I can talk to most of the modules on every car? Or
Oh, that is a loaded question. Okay, first of all, there is no one scanner that does everything. Okay. At the shop, we probably had 15 different scanners. So we had some factory scanners like factory BMW, factory Mercedes, factory Saab, factory Volkswagen, factory GM. So we had a lot of factory scanners. We also had quite a few aftermarket scanners because they do different things well. The scanner I use every day in my preferred scanner is my Snap-on. That's my triage scanner. That's the scanner that got turned on when I got to work in the morning and got turned off when I went home at night. And I used it all day to figure out, do I need to get a different scanner? Based on what I find on triage, I may have to go get a different scanner, depending on what I find. Does a Snap-on do everything? No, it doesn't. The Autel is, they make a scan tool. It's about $2,700. It's quite a bit less money than the Snap-on. And it actually does quite a few things the Snap-on doesn't. It does a great job. It's a great bang for the buck, but it doesn't manage data or graph well. So I can reprogram a key. I might not be able to program with a Snap-on, but I can't go out and drive a car and collect the data that I want to collect to do an advanced diagnostic. So, there's just not a one size fits all. I assume if I went to your kitchen, you have more than one pan.
yes,
Is that a safe bet?
yes.
Okay. Why? Well, what is the perfect one pan I need to cook everything? All you got to do is stay up to about 2 or 3 a.m., watch an infomercial, and they'll show it to you, right?
Ask my wife.
Yeah, the reason why I was asking is because just like something, I don't know, to me it seems silly because I did a transmission service on a Chevy, what was it? Chevy Captiva 2013, and I couldn't reset the light with the Snap-on. I tried the Autel, so I was actually just planning to buy a launch, just because I couldn't reset the service light for the transmission.
Yeah,
service.
you know what? If the Autel can't do it, the launch probably isn't going to do it. You should have been able to reset the service light. Or sure it was a service light and not a code.
No, it was a service light. I was asking for
Okay.
the transmission service.
And sometimes the service lights you can just reset through the dash controls and you don't need a scan tool.
Yeah, I looked for it and I couldn't find it. Not even on the. That's why I say it's silly, because I'm like, come on, it's just a service. It's not like
Right.
wrong with it.
No, and it's frustrating. We bought an OE level Porsche scan tool for $800 that's laptop based, just so we could turn off the reset when we did an oil change on a Porsche Cayenne.
Yeah, no, yeah, that's actually why I was asking, like which one you can say, oh yeah, no, this one, is the one that I don't have. I have the
Yeah.
least issues with this scanner, but like you said, there's a little bit of everything.
A little bit of everything. And it's embarrassing when you're taking care of a customer's car, especially a 7 or 8-year-old car, and you can't even turn off their maintenance light for something because you've invested tens of thousands of dollars in tooling and nothing you have turns off the stupid light. It just makes you look stupid. It really erodes customers' confidence, and customers have no idea what's involved with all these stupid lights they put on and all these reminders and all this maintenance and what you need to get into these different systems to reset stuff. It's just crazy.
Yep. Yep.
Another name for the network structure is which of the following?
Topography.
Topography. So here is a little case study. So I'm going to walk you through a little diagnostics that we did on a vehicle. And this happens to be an 05 Chevy Avalanche. And it came in one day and the customer complained that intermittent loss of power and the car wouldn't start. And we talked to it and we had some history codes for loss of communication in some of the modules. But we couldn't get it to not start. We couldn't get it to act up. And the customer didn't want to leave the car. The next day, the car got towed in because it didn't run. And we hooked the scan tool up to the connector. And we got this: no communication with the vehicle, check diagnostic link connector, make sure the key's on. So this is a car we were able to connect to and talk to yesterday that today I'm getting crickets. It won't talk to me, but yet yesterday the car ran and today the car doesn't run. So I don't think it's my tool. I really think it's the car's broken because I was able to talk to it when the car was running. So what we did is we went, and here is our 16-pin DLC. And some of these pins are standardized. So pin 16 right here that you can see is always battery power. And pins 4 and 5 that you see right here are always going to be ground. And they're going to go over that in the article I assigned. Pin 2 over here is my network pin. And this is my network pin for the communication protocol that this car uses, which is called Class 2. It's a single wire network. And what we did is we used an adapter that has a spade that plugs in there so that I could use the round test lead to plug in here. Because we don't want to put that round test lead into a spade because then we would damage it. It would open it up and then it wouldn't communicate with a scan tool or work in the future. So we never want to force connectors open to put a tool in. We always want to use the tool that fits just perfect. So what we did is we hooked up to a lab scope, and on the lab scope, I'm looking at one millisecond each division. So and I'm looking at 2 volts. So where this is where 0 volts is, where the 1 is. So there's 2 volts, 4 volts. Oops, I'm on the wrong screen. So here's 0 volts, 2 volts, 4 volts, 6 volts, 8 volts, 10 volts. And where the red line is, which is what we're measuring, is right about 11 volts. So we can see that we're staying pretty close to 11 volts. Now this system, going back to Alberto's question, how do I know whether that's okay or not? This system only operates between 0 and 7 volts. So 11 volts is well above what we should be operating at. So what's happening is, since I have 11 volts, can I see anything trying to move between 0 and 7 volts? Or do I just have this 11 volts here all the time and we can't do that? And so it's kind of like trying to have a conversation next to a big speaker at a rock concert, right? You're moving your lips, but who knows if there's any sound coming out because you have all this volume that's jamming you out or overriding you. And that's what we're having here electrically. We have this 11 volts, and with 11 volts on here, the transistor can no longer go between 0 and 7 volts. It can't pull it down because it's got this 11 volts that has much more amplitude than that 0 to 7 volt range. Well, with this on the line, no one can talk because no one can hear. So the question is, where is the 11 volts coming from? So we went to the wiring schematic, and here's our pin 2 on our diagnostic connector. And it comes over to what's called a splice pack. So GM used, and some other manufacturers use, a splice pack where we run a wire in, and then we have all these other modules all run a wire into this pack. So instead of going and taking out all these modules and looking at them, we can just go to the splice pack, unplug it, and test them one at a time to see where my 11 volts is coming from. Going back to the conversation, is this easier or harder? Well, it depends. Am I just trying to take a car apart, or am I thinking about what's going on? So we went to the splice pack, and here's a picture of it. We took the back out of it, which is called the comb, which connects all these. And we went through and we touched each of these, and we found one of them has 11 volts, our system voltage. So now we know where it's coming from. Now I could cut the wire going to that and probably make sure I could talk to everybody else, but we didn't want to fix on the wire. Instead, we went back to the schematic, and we saw that pin H had the 11 volts, and it goes to another splice pack. This other splice pack is in the B pillar right by the driver's door. So now we had to take the seat belt cover off and take that stuff and get in there. And this is a much smaller splice pack. And we tested, and again, we found the wire with 11 volts. So we went to the schematic for that splice pack, and we saw that it was pin C, which went to the memory seat module under the driver's seat. That's where my 11 volts is coming from. Does that mean I need a module? Well, wait a minute. Don't we have some connections here and some wiring here? We have other possibilities, don't we? So what we did is we went to the memory seat module, and we unplugged the connector. And the reason why we unplugged the connector first, because it was easier to get to the module. And when we did that, the voltage dropped to 0 volts. So the voltage is coming from either the module itself down here or the connector, right? It's coming somewhere in this range. So then we tested the other side, and we did verify we were getting 11 volts. We did some wiggle testing where we kind of played with it to see what's going on. And what we found out is it wasn't the module, because when we unplugged it from here, we still had 11 volts. But when we unplugged it from here, we didn't have the 11 volts. So something between here and here was putting 11 volts on a wire. But those are just wires and connectors. So let's take things apart. And this is what we found. So this is the little plastic piece that holds all the little electrical pins in. And see this little corrosion right here? Well, one side is our class 2 data. The other side is 12 volts. So this corrosion was able to make connection inside a connector. Cause the car to intermittently not start. Cause us not to be able to communicate. Once we cleaned that up and put it back together, we were able to see that the class 2 data works. And how it works is it's normally at 0 volts. And then when a computer has something to say, it goes up to 7 volts, and then goes back down to 0, and then up to 7. So you can see when we had 11 volts here the whole time, how can we go to 7 volts when we're already at 11? And I'm only designed to go up, not pull down. So kind of a needle in a haystack, kind of a weird thing to have a connection like that. But was it really that hard to find if you were disciplined and used the things that we've taught in this class as far as gathering information, trying to understand how something works, and then looking at the schematic and just kind of walking through to figure out where things come from?
Mr. Brian?
Yes.
I have a question. So I know this is supposed to be it's actually able to go up to 7 volts. How this one is different from a computer when it comes to like testing? Because I know if this one went up to 12 volts, it's not that. Can that cause to fry the network or no?
No, normally not. These, because the systems are usually pretty protected. They're usually really resilient to being shorted to battery power or shorted to ground and not letting the smoke come out of a computer for network faults. Networks are really built pretty resilient, and the transistors that they use to toggle them seem to be pretty resistant. So, especially on newer stuff, CAN stuff that we'll get into, I've deliberately applied battery power and deliberately applied ground to short a network for either diagnostic testing or research. And it was part of a book that we did a couple of years ago. And the company I was working with, I'm like, I don't know if we should do this, especially when one of them was my car. And they're like, hey, we got a credit card. We blow a module out. We're just going to buy you a new computer. Oh, okay. Let's see what happens then. So, it's amazing how many things you'll try when you have a company going, no, we want to know what happens. And if something bad happens, we have a credit card. We'll just buy whatever blows up.
Yeah, and I'm assuming when you in this kind of case study, like when the customer bring the truck over to you, how can you explain that to the customer? Like, because some customers, I'm pretty sure they're like, well, it doesn't start. I want you to
I'm
pick
sorry,
the phone
you're
when
dropping
starting.
out. You're dropping out quite a bit, Alberto. Just try again.
Oh, sorry. Can you hear me?
Yeah, I can.
Every time I'm talking, I have to be so close to the screen. So yeah, in this case study, how do you explain to the customer like the procedure for the diagnostic? Because I know some customers will tell you, well, you want to go after the network, but my problem is a no start. You know what I mean? And some people they think that is two different things.
Right. And theoretically, they could be two different things. But how can I diagnose a no start if I can't talk to it to find out is the crank sensor working, is ignition working, all those things? Obviously, we're able to quickly see that we didn't have spark and we didn't have fuel. So that's a computer problem because the computer turns both those things on. On GM vehicles of this year, the no crank condition, is controlled by the body. The starter is controlled by the body control module, but permission comes from the powertrain control module. So in this case, the car didn't crank over. Well, I need to go talk to the body control module. I can't get on the network, and I know that the network is used to make the engine crank over. So, it was just kind of one of those, you got to start somewhere. I'm a big believer in fixing what's obviously broken first and then see what happens. Instead of going, yeah, I know this isn't working, but I really care about this. Especially with computers and network systems, it's amazing how many times something you don't think has anything to do with what the customer's complaining about is actually the problem. For example, we had a vehicle, and I think I mentioned this in lighting. We had a vehicle with a complaint of the backup camera not working. And long story short, it turned out to be a right front headlight assembly, and the leveling motor didn't work. And it was blowing the fuse for the circuit for the backup camera. And the customer's complaint was only about not having the backup camera. So to fix the backup camera, we had to put a new headlight assembly in it. And the part was $950 plus the time to replace it, plus the time to diagnose. So, you wonder why customers are confused and they lose confidence in a shop when I'm telling you, you need a new right front headlight in order to fix your backup camera. And you think about how many customers would go, this guy's crazy. He's trying to rip me off. So it's really important that we explain to the customer the process and are transparent on that. On this particular case study, I went to as far as the first splice pack for my initial hour. And once I found that I had to go further, at that point, I went back to the customer and got more money because of the amount of disassembly required to get to the next splice pack. So, so the customer so it wasn't like we just started taking the car apart and surprised the customer with a bill. That's illegal in California, as you all know. So we started with our initial diag, got to a point where we had information, and then gave the customer on a price to go and do the diagnostic based on the information we'd already gathered.
Mr. Brian, it seems like even with basic stuff, more and more it's network and computerized.
It is. And the amazing thing about that, if you notice, what did we fix this with? Basic stuff.
Mr. Bryan, in the example that you just gave, you had basically an electrical contact between the pins of that connector.
Yes.
And you chose to clean up the connector, put it all back together, as opposed to scrapping the connector, getting a replacement one that didn't have any damage to it. Why did you make that choice when the existing connector already showed some damage to it and the ability to make that electrical connection between the pins?
Great question. So in this case, it was the connectors themselves were not really damaged. There was a little bit of corrosion in there, but the thing that was bridging the contact was the corrosion on the plastic. So it was easily corrected. And then we put some dielectric grease on it. The other issue is you saw that short little harness there, had a lot of wires in it, and it was made out of unobtainium. So at that point, it was not available new. We would have been trying to get one from a junkyard, which would have tied the customer's vehicle up for quite some time, and the hopes of even trying to get the right one delivered to us. So the path of least resistance was to clean up the plastic, put some dielectric in, plug it back together. We knew that since it was bridging between those two across that corrosion, removing that corrosion would solve the problem. And we weren't worried about a warranty issue for the 2 years we had to stand behind it. So that's why we made the decision we did. So yeah, great question, because there's a lot of factors that go into that decision between repair, replace, recondition. There's times that I'll dig my heels in. I don't care that the car is going to sit there for a week. We need a new one. There's other things like this that, yeah, I can clean it up. And if it was my own car, I wouldn't be buying a new one. So it really is on an individual basis, just like with your car, Rob. Looking at yours, you need the ignition switch, you need the connector. I mean, there's just cut and dry, no doubt about it. If you only do one, you'll be back there in a couple months of driving the car. And I know that from experience of only doing one and not the other. Because I've replaced those before. Like I said, Napa used to stock the things. It used to be fairly common. And so you kind of want to look for the cause and effect. In this case, the car had been in snow and had been in adverse weather, and it come from a place they used salt on the road. So I think that's what caused the corrosion initially. And so by cleaning all that up and using the dielectric, we knew customers living here now, that wasn't going to come back. That wasn't going to be a continuing problem.
Thank you.
You bet. Great question, though, because there is no one size fits all. There's times I'll repair something. There's times I'll refit a pin. There's other times I'll go, you know what, we need a whole new one. And yeah, I know it's a week away, or I got to get it from Detroit. We're going to pay an extra 20% for shipping to get it here in 3 days or whatever. But that's what the car needs. And it is really on a case by case basis. We can't just do a blanket. You always do it this way, because you don't. I used a technical term called unobtainium. We use that in the automotive industry for a part that is unobtainable. We always say it's made out of unobtainium. So we'll try to order a part, or I'll ask my service advisor to give me a part, and they'll come back and go, it's made out of unobtainium. You're going to have to figure out something else.
I had always been taught that it was just a level of damage. So if you saw a level of burn on that particular piece, then you need to get rid of everything that touches that level of burn. But you're telling me something a little bit different.
Well, and you're correct. I mean, the level of burn you have, both pieces need to be replaced. But say we couldn't get a connector. You couldn't get one from a junkyard. You couldn't get a new one. You couldn't get anything. Okay, now what's option two? Do I cut away on that connector and use a pin that's not part of that connector and get a new switch, because I can still get a switch? You start going through what is actually available to me now, because that does unfortunately sometimes affect the ability to repair. On the other hand, if it is a 6-year-old car or 10-year-old car, and it might be fairly minor damage If it was a 30-year-old car, that I would, yeah, we can clean it up, we can get away with it because parts aren't readily available. But I called the dealer and they got 10 of them on the shelf. Send me one, because obviously they're having a problem with it. And B, the parts readily available. It's going to kick that can down the road for the customer another 6 to 10 years on the life of that part, because it took 6 to 10 years for it to get this bad. So sometimes we'll replace things that are marginal because the availability is so good on them, because we don't want to have a problem, or we know that, hey, the manufacturer obviously did something a little off here because the dealer has 10 of these in the box on the shelf.
I got it. Thank you.
And that's what I meant by it's fluid. I mean, I agree 100%. Something's badly burned on both sides that needs to be replaced. The next question is, can we get the replacement parts? In this case, it was corrosion, not burn. And it was not corrosion in the connector. As far as at the pin, it was corrosion between the pins causing a alternate path of current flow, which was easily corrected. So it wasn't a lack of connection, it was too much connection.
So parent, just a basic question. So in the anatomy of troubleshooting, is the first red flag coming from the dashboard and then you use the scan tool?
It depends. Many times, yes. Many times the dashboard that, service engine soon now or check engine light is like a baby crying, okay? Right? The baby crying is what gets your attention. Now, does it want more food in? Does it have a dirty diaper? Can it not sleep? Did it drop its toy? We have no idea to what. We go in there and investigate. We also have issues on the vehicle, and we have systems on the vehicle that do not have a warning light on the dash. So, for example, there was just a Toyota at the shop, very similar to mine. The transmission was not shifting correctly. There was no codes. The computers were happy. We inspected the fluid and found excessive aluminum particles in the fluid. And that is because it had a bearing that was slipping inside the case of the transmission, and that aluminum particles were getting into the valves, causing it not to shift correctly inside the transmission. So there was no codes for that. There was a customer complaint on how the car drove that we were able to duplicate. And then there was a knowledge of what fails on that transmission, which we found through an article in a trade magazine. There was no TSB, but what I did is I went to a Automotive Transmission Rebuilder Association website, ATRA, and they publish a magazine every month. And I don't need to pay anything to go search old issues of magazines. And I did a magazine search and found articles for that transmission and found that exact problem. And that research on their site took me less than 5 minutes. So yeah, I'd like it to start with a check engine light and then plug in a scan tool, but I'm not always that lucky.
Mr. Brian.
Yes.
For a newbie, so am I understanding it correctly that the case, whatever problem the car had, started with not starting, the car not starting, and then you did the diagnosis and found out that there's a corrosion in one of the, what did you say, connectors?
Yep.
Under the
seat.
seat?
Yep.
That's the connector that is used to adjust the seat.
Yep, goes to the little module that remembers where you wanted the seat and that you want the seat in a different place than your husband does.
Oh, okay. And you said that the corrosion was probably caused by the snow because that car was used in a place where it snows?
Yep.
Oh, okay.
Yep, snow and salt, and that gets in there. And, we see this here where people, go to Mexico and drive their cars on the beach and stuff. We see corrosion issues. And what happened is the corrosion got on the plastic and it made a parallel circuit, right? It went from the power source to next to it that wasn't supposed to have the power, and it made a circuit connecting the two with that little corrosion I showed you. So this little corrosion right here was just enough to make an electrical connection between these two metal pins. So by cleaning off this plastic, just scrubbing it and getting rid of this corrosion, there was no longer that parallel circuit.
Okay. Thank you. It's
So
hard
in
to
this
understand.
case, it was all labor and no parts, basically. And this also always leads me to the discussion, because I have customers all the time ask me, well, if I have you do the repairs, do I still have to pay you for the diagnosis? And my question is always, well, if I spend 4 hours finding the problem and 10 minutes fixing the problem, what should you pay me for? The 4 hours, the 10 minutes, or both?
Should be both, right?
Could be both. Where was the skill here? Scraping the stuff off the plastic, or finding out that that plastic is what was causing the car not to run?
Diagnosis.
Exactly.
Of course, the customer comes back and says, well, the other guy would have found the problem in 1 hour, not 4 hours.
Right. Well, and that's why you have to give a price up front in California. So what I do is I look at a job like this, and based on my experience, I give a price. And if that takes me to get to what I'm going to do, if it takes me 2 hours, I'm making money. If it takes me 4 hours, I'm losing money. If I told him that I want 3 hours labor to do it. So if I price it at 3 hours, I'm going to do this for 3 hours. I'm going to trace this circuit for 3 hours labor. That's going to involve me taking anything out, doing whatever till I get to the end and find the problem. Now, what? Can I beat the 3 hours that I'm getting paid? Can I do this in 1 hour or 2 hours? Or is it going to take me 6 hours? Because I've already locked in with the customer, and we've both agreed that that price is fair. And generally, with technicians, we talk hours. With customers, we talk dollars. So my question to you is, what would having your car start and run and be reliable again worth? You had an intermittent problem, you just got it towed into the shop. How much is it worth to be able to get in your car, drive it, and know it's not going to do that again? Is that worth $400? Would you feel that, man, that was a fair amount of money, but at least my car's fixed and it could have been a lot worse? Right? So, I mean, that's really what you're down to, is you're down to what's the value of the repair. How long it takes me really has nothing to do with it. Would you feel better if I took 2 days because I didn't know what I was doing and charge you $400? Or would you rather me get it back to you this afternoon and charge you $400?
So Brian,
Yeah.
Where can I find like the description of like for the networks? Because just out of curiosity, I'm actually in Pro Demand looking for just random BMW.
Right. I'm not good with ProDemand because I use AllData, but you'll definitely be in the wiring section is where you'll find it. You should have network wiring, and most manufacturers have a separate wiring schematic just for the network.
Okay, because I was looking for the topography of the network.
Yeah, topography is tough. Topography is only in a few scan tools. Most manufacturers don't give it to you. Topography is great, but it's tough, and sometimes you almost have to draw your own.
Okay, because now right here it says F can and then K can. I'm like, okay, now it's something else.
See, now you get it. So those are two different networks. They're both controller area networks, but they're different, and they may use the same or different protocol. And once you map out kind of where they're on the wiring schematic, and we'll get into this on Monday, I'm going to talk about, because I don't think it's in the next couple of slides, we're going to talk about gateway modules, and gateway modules are translators. They talk multiple languages, so they're able to talk from one network to another. So as you look in the wiring schematic, we can figure out where a gateway module is and how it communicates. But before we do that, see how much of my rambling you all remember. And a class 2 data network operates in what voltage range when it is toggled high and low, or on and off, however you want to put it?
0 to 7.
0 to 7. Absolutely. Number 3. The problem we had is ours was at 11. That's why it didn't work. So it's supposed to go from 0 to 7. Boy, it's amazing after all that talking, you actually remembered what I taught. That's amazing.
Sir Perrin,
Yes.
why is it important to know whether it is LIN or LAN or CAN? Which network you're going to be dealing with?
Oh, great question. Okay. So the reason why is because a local interconnect network works on different protocols, different strategies than a CAN network. And all CAN networks are not the same because we have multiple speeds of CAN network with different rules. FlexRay has a different rule. Most has different rules. So, or like Class 2 that I'm talking about here, which GM used forever, is a separate protocol. So it's important to know what you're working on. Do you need to memorize that? No, you need to memorize that there's different networks and they don't all work the same, and that you can go look up how it works when you get one in front of you. That I think you need to memorize. Fortunately, as of 2008, with the exception of 2 cars, everything talking to the DLC uses high-speed CAN, and it has some very consistent rules with that. So if I'm working on anything 2008 or newer, and I'm working at the diagnostic link connector trying to solve a communication problem, that's all going to be high-speed CAN or CAN-C, and that has some specific rules. And I'll go over that stuff with you next week. That stuff we should know because every car on the road uses it. So if I'm going to work on these cars and everything from 2008 uses it, and we started using it in 2003, that's, over half the cars on the road today use that. That's worth knowing if this is what I'm going to do for a living. That being said, I am teaching a network class right now for my SMOG update, and it is amazing how many technicians out there, and I chose it because CAN is now 12, 13 years old, and we're starting to see some neat failures in it. And what I can tell you is 90+% of the technicians out there are not equipped to deal with a network fault. They have no idea. Once the scan tool doesn't talk, and once the fuse is not blown for pin 16, they are lost. They have no strategy. And that's why I wrote the class, and I'm teaching the class, and I'll be doing that for this year and next year for my update training for my SMOG techs. But that's right, because what I saw in industry and the cars that were referred to me at the shop are cars that they should have fixed. I mean, they just weren't that hard. I mean, they were really, really not that hard. Low-hanging fruit, didn't even need to go get a ladder to solve these problems. And there are problems I'd solve in 5 to 10 minutes. And yet they forced the customer to drive the car for me. They kicked it out. They'd already spent time on it. And so that really showed me that as an industry, technicians are really ill prepared to diagnose network systems. So again, it kind of comes down to, if this is something you want to do for a living, this is a great growth area, because this is an area that, guess what? The people that have been doing for 20 years, most of them don't know much about this either, and they stink at it. So you're kind of getting on that even playing field. When I got in the industry, I couldn't learn all the stuff people before me knew right away, but the stuff we're learning on the new vehicles, I could learn it at the same speed they could. And so, that's why I didn't, concentrate on some of the traditional things that people were doing when I got in the industry, and really spent my time on the new stuff that no one wanted to learn and no one knew, because that's where the future was. And certainly as we look at electric and hybrid vehicles, guess what? Everything's networked.
So, Mr. Brian, is it really, really more difficult to be an auto technician now or mechanic compared to before because of these new technology and computer that, not to be so offensive, before is, the mechanics are thought to be just skilled people,
Right.
and not really like, they probably are the ones who didn't excel academically. Is
Right.
that, so
No,
now,
I understand. No, all I got to do is watch any Law and Order episode or any movie, and mechanics are usually ex-con drug dealers or users that might have graduated the 3rd grade. So I do know the stereotype. And yeah, there was a time going back 70 years, 60 years, that people that didn't do well in school would end up in the trades, whether it's as a mechanic or whether it's as a plumber or any other trade, because it was the monkey see, monkey do, right?
right.
I need you to take this alternator off and put it back on. I need you to take the alternator apart and put new bearings in it. And so it wasn't a matter of how things worked. It was about, here's how you take it apart. Here's how you look at it to see if these parts are okay or not. And here's how you put it together. And you're right, that's what it was up until the 80s. And in the 80s, when we really started seeing computer systems come in, we saw a lot of those guys do one of two things: either get out of the auto industry or move into heavy trucks, diesel, because diesels didn't have those emission controls on them and they didn't have computers on them. So they kind of moved into this other stuff. And then in the 90s on light duty diesel, we started seeing computers. And after 2000, we saw it on heavy duty. So you're right. Today, it's a very different skill set. I am more things I do with my hands are replacement and not adjustment. So for example, if you drove in a 1970 Monte Carlo and wanted a tune-up on it, depending on who did the tune-up could have a huge difference on how that car ran. Because there was a lot of stuff that was adjustment, a lot of stuff that was feel, a lot of stuff that was, hey, we do this and we do this, and you do it in order, and there's things you needed to check. So there was a lot of those processes that was the difference between a good job and a bad job that a customer might experience. Today, that's not really the case. Today, we're going to put spark plugs in. So unless we drop one, crack one, don't put it in all the way, something like that, we're not gapping them. We're not there's no carburetor to adjust. There's no timing to adjust. We're replacing parts that have worn out. So on the replacement, on the parts side, I think it's gotten easier in a lot of ways because that feel, that touch and feel is out of it, or that experience of adjustment is out of it. On the flip side, what you're talking about, this part is completely different now because we fix it up here before we fix it out here. There's a ton of people in shops that have these that take parts on and off. There's very few people that have this and are able to apply just the things we talk about in this class: apply electricity, apply Ohm's law, apply discipline, really, right? Because what does it take for a lot of people to be successful in school? Takes a certain amount of discipline. Gee, I have homework to do, but someone's inviting me to the movies. Someone would like to play cards. Someone would like to watch. We have all these distractions, and it takes a certain amount of discipline to do the work that we do in school in order to be successful. That discipline carries over to successfully fixing cars. No different than Rob's car. Rob used discipline in, hey, here's what I got. Here's the symptoms. Here's what I think. But before I jump there, let's do some tests and make sure I'm going in the right direction. And that is something that a lot of people struggle with today. There's a ton of people that want to go out and put parts on cars.
Mr. O'Brien.
The mental part, and those are the people that are retiring right now, and those are the openings. I can't tell you how many emails I get of people looking for not even a top tech. And techs are broken down to A, B, and C techs. I'm an A tech. A B tech is someone who's real good at taking things on and off, doesn't have a lot of comebacks, understands how the industry works, but is weak on diagnostics and usually weak on electrical. A C tech is someone who is competent in the shop, who can do basic services, oil change, brakes, those kinds of things. Isn't going to do more advanced R&R stuff, not going to do any rebuilding of stuff, and does no diagnostics. So that's what we talk about A, B, and C techs. And if we actually look at the labor times in a manual, it actually tells us what technician level is required for that job. I have people all the time contacting me looking for a B tech, not to mention an A tech. A techs right now are few and far between. I could go back to industry tomorrow. I have people call me asking me if I'm tired of teaching yet. My boss that I worked for 8 years, I was talking to him. We were in COVID and stuff, and I was a little frustrated. He goes, I know you were joking, but if you ever want to come back to the shop, I'll fire 2 people to make room for you. Because A techs are so rare today. Even B techs are hard to find. I have people looking all the time for B techs, and that's why I approach entry level a little differently than some people do. Because I approach entry level with, let's use this, especially with us being online. How many parts can I have you take on and off your car at home? I mean, really, what are we really getting from that and the expense involved, as opposed to if we understand how things work, now we can ask good questions. And I told you at the beginning of this class is about helping you ask questions. Because if we ask questions, we'll find answers. And I know I don't have all the answers. That's why I'm still asking questions. And that's also why I really like what I do. I'm not tired of teaching yet. I really, really like it. Some days I miss being in the shop. I like working on cars. I like doing that. But and I miss the challenge of it. I enjoyed that, because every day it's a new puzzle.
Connector usually.
What's that?
How can you depin it if you need to depin a connector?
They make special tools for taking the pins out of connectors.
What if it's like glued in and the connector is not able to come out all the way? It's like solid.
They normally don't glue them in. If it's a molded connector, it's not serviceable and the pin won't come out. Most of them have a release to get the pin out of the connector.
Oh, it's because I have seen a lot of them. They are molded completely.
That's rare.
So back to sorry, didn't mean to interrupt.
No,
back
no
to
worries.
the A-Tech. So would that translate to like a supervisor or like a
No,
lead in
not-
the shop? Would you be doing the diagnostic and then would you hand it off to the B-Tech to do like the whatever the service, or would you complete the whole job?
Some of it depends on the shop. So where I was at, because I'm old and lazy, if I diagnosed an engine that had to come apart, I wouldn't take the engine apart. It would go to a B-Tech. If I diagnosed, hey, it's a bad transmission, I may or may not do it. It depends on how easy it is, right? If it's easy, I'll do it myself. If, oh man, that thing looks really ugly and hard, yeah, I'm going to give that to a B-Tech. So I was fortunate. I worked myself into a situation where I could pick and choose which jobs I wanted to keep. And my boss and I both figured out that we both made a lot more money and we're both a lot happier when I did that. It started out with him wanting me to do everything and see jobs bumper to bumper. And he'd try to give other people diagnosis, which didn't work well. And I'd have to redo it. And then the last job I kept, I sold her a really good job, had a lot of hours in it. And I'd take a tranny out of a car, both exhaust manifolds. It was about a 20-hour job. Good dollars, good jobs. It beat me up so much and took me longer than it should. We both decided that was the last time I was doing that. And so we just got a lot better that, if it's this, I'm going to have someone else do it. I mean, it came down to even a lot of times timing belts. I'd sell a timing belt job and I'd have one of the B-Techs do it. So I got to where I was doing less and less, as far as that type of work that off of my diag or timing chain or things like that. And a lot of it because my boss didn't want me tied up for 10 hours or 12 hours or 2 days on one job, because I was diagnosing, 5 to 10 cars a day and doing repairs on them. And so, and a lot of the repairs I'm doing are 2 or 3 hour repairs. So it was very efficient that way. So a lot of the repairs I did, because I was doing computer diagnostics, drivability diagnostics, or anything that could turn the light on the dash, it went to me. So it didn't matter if it was airbags or anything. So I got to do a lot of that kind of stuff. And I did most of the hybrid stuff. I did almost most of the diesel diagnostics. But if once I diagnostic, it went to someone else to pull the cab off the truck and take the engine apart. So it was, so that worked well for our system. I've certainly been the A-Tech where, I get it. And I'm doing everything on it, and that's not uncommon. It kind of depends on the size of the shop and the quality of the other techs. Also, a lot of times an A-Tech does get moved up to a shop foreman, which is what I was at in the last shop. And depending on how the shop's set, the shop foreman may be a working shop foreman, or he may just be supervising and just helping out where needed as a shop foreman and not working on any specific cars himself, unless it's a headache car that the other techs haven't been able to fix. And now he's kind of the last stop of trying to save the customer in the car. So I hope I answered the question okay, Christopher.
Yeah, no, you did. I was just wondering because I did the same thing in my last line of work. You know, I started off as a grunt. You know, I worked my way up to supervisor, delegator, and like you said, it's true. Once you get involved in the small aspects of the job, you lose sight of the whole picture. So I was just wondering, you know, you were probably in the position, like you said, you would diagnose, let people know what's wrong, and then step back and delegate and make sure everything's going according to plan. And it seems like you said that's more efficient because your time is more valuable than you can diagnose 10 other cars instead of spending 10 hours on one car.
Right. And my diagnosis is most likely going to be correct compared to we just put a $400 module in based on what someone said and the car runs the same way. And I can't go back to the customer and sell something else. You need to figure this out. I mean, I've been there too. And it's like, then why'd you give it to them? And I'm sure you did also in your previous shop, Christopher, where people would get assigned things. You said you shouldn't give this specific task to this specific person. And then it hits the fan and then it's like you're on cleanup all of a sudden.
Exactly.
Mr. Perrin, an OBD2 would be able to diagnose all kinds of networks.
No, OBD2 is strictly a guideline for an engine management or powertrain management system. And we're going to get into exactly what OBD2 is. OBD2 really has nothing to do with networks, although modern OBD2 vehicles have networks and we're talking them through the same 16-pin diagnostic link connector. But that has nothing to do with OBD2. And we had vehicles with networks prior to OBD2. CAN has been around since 1992 on Mercedes. You couldn't access it, the DLC. It was strictly for sharing information between modules. But we've had network systems going back to the 80s. So network and OBD2 are two different things. So just because you're plugging into that 16-pin connector doesn't mean it's OBD2, and it doesn't mean all the functions you get there are OBD2. OBD2 has some very, very strict legal definitions of what it is and how it works in the engine management system. And we'll get into that because I have a whole PowerPoint presentation on it. We'll talk about it. So one final question and we'll call it a weekend, folks. The Class 2 data network uses how many wires for network communication between the modules and the diagnostic link connector?
One.
One.
Mr. Brian.
It's one because that's the only one wire I was testing on pin 2, right?
Yes.
It's only testing one wire. So Alberto has it right. It is party time and it is the weekend. So everyone have a great weekend.
Thank